Good day everyone. Today we will discuss about set theory. It was created by George Cantor. By definition, it is a well-defined collection of distinct objects. So when we say sets, it is usually written using brackets. So each object in a set is called an element or member. So when we say element or member, those are inside the set. So again, what is an element? Element is an object, number, letters, or item that belongs to a set. Elements are written inside the brackets. It's separated by commas. Example, a set of A is 1, 2, 3, 4. So that's a set. Let's have another example. A set of apple, mango, and banana. That's apple, mango, and banana are the elements of a set. Just like 1, 2, 3, 4, that's or the element of the set. So the set, when we say set, it would be a set if it is enclosed with bracket. But it doesn't enclose with bracket, it will become an element. So the symbol for element, that is the E or capital italic E. Let's have another example. The set of 1, 2, 3, and D. Here, the element 1, 2, 3, and D, these are only elements, but it will not consider a set because when we say set, it should be distinct. If all the elements are number, it should be all numbers. No letter should be included. Okay, let's have example number 1. The set of all days in a week. So we know that days in a week are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So that's all the set of all days in a week. But if you're going to include a month like February, March, on those given answer, then it will be classified as a set because set is a distinct, well-defined object. So let's move on to example number 2. The set of all letters in the word mathematics. Again, the key word for set, it has to be distinct, well-defined, and no repetitions of letters allowed. So we're going to crash out those letters that are shown. Those are. So we're going to crash out those letters that showing twice. These are M, A, T, and that's it. So the remaining distinct letters in the word mathematics are M, A, T, H, E, I, C, S. So that's a set. So if we're going to write them all, the word mathematics, inside the bracket, then it is no longer classified as a set. Okay, you have no idea what is set. Let's have here another example. The set of vowel letters in the alphabet. The vowel letters in the alphabet are the set of A, I, O, U. So that's it. That's the only vowel letters in the alphabet. For number 4, the set of integers. More. So I would prefer that it would be positive integers. So more than 6, we will start with a set of 7, 8, 9, 10, and so on. The 3 dots there are called ellipses. So important reminders for set theory. Order doesn't matter and repetition is not allowed. So the order can be rumble inside the set. So there are 2 types of set notation. First, Rule method or set builder notation. It is used to describe the elements or members of the set by a property or rule. Let's have here an example. The set of prime numbers less than 10. So by the definition, you have to describe the elements by a property. So it would be, and it will always be, with this starting point x such that x, the slash there will be called such that, or will be read as such that. Prime numbers less than 10. For this, you have to transpose those less than into symbol. That's the property or rule in math. The second set notation is roster method or listing method. The elements in the set are enumerated and separated by a comma. Let's have here an example. The set of prime numbers less than 10. So here for roster method, we will going to provide the answers. We will find the numbers that are prime and also less than 10. When we say prime numbers, those numbers that can be divided by 1 and itself, that's a prime. If it cannot be divided by 1 and itself, then it would be called a composite numbers. A prime number less than 10 would start with 2 because 1 is not a prime number nor a composite number. Next is 3 followed by 5, 7, and 9 is not a prime number because 9 can be divided by 3. Prime numbers can only be divided by 1 and itself. So correction, the set of prime number less than 10 would start with 2, 3, 5, 7, and 9 is not part of the element of prime numbers. Okay? Now let's move on to finite set and infinite set. For finite set, elements are limited, countable, and can be identified. It means that those elements that you can count and can be identified. Example, the set of positive integers less than 15. The symbol for positive integers is a z, then plus on the top, then less than 15. So by this example, we can identify the positive integers less than 15. Remember, integers are whole numbers, positive and negative, but here we're looking for only positive less than 15. So the positive integers less than 15 are the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 14. Get it? Now let's move on to infinite set. Infinite or elements are uncountable, unlimited, and elements that cannot be identified. So that's the definition of infinite. Example, the set of whole numbers. Meaning, you have to write all the whole numbers whenever you want. So whole numbers will start with 0, 1, 2, 3, 4, 5, and so on. There is no indicator where you will stop for infinite set. Now let's move on to unit set. A set with only one element, that's a unit set. Example, a whole number greater than 1 but less than 3. When we say greater than 1, so the answer would be 2. And less than 3, the answer is also 2. So by this, we only have a set of 2. Now let's move on to empty set or null set. A set with no elements, that's for empty. Example, an integer less than 2 but greater than 1. less than 2 but greater than 1, there's no integer because integers are positive and negative whole numbers. We cannot tell that 1.5 is an integers because by definition integers are only whole numbers. So there's no element between 2 and 3 that are integers. So the answer is empty. So empty or symbolizes or denoted by this 0 then slash or the bracket itself. Universal set, all sets under investigation, and the elements there are large fixed set. And it always denoted by the symbol capital U. Example, a set of positive integers. So capital U, positive integers are those starts with 1, 2, 3, 4, and so on. Or any number coming from positive integers. That's universal set. Now let's move on to cardinal number. Cardinal number, the number of elements or members in the set, meaning you just count all the elements inside the bracket or inside the set. And it always denoted by the symbol and close and opened parenthesis, any letter in a set that corresponds the universal set. Example. So example for universal set are the elements A, E, I, O, U. Then for the cardinality, we need to just count all the elements. So the cardinality of E is 5. Practice test number 1. If B is equal to the set of 2, 4, 6, 8, 10, which set builder form is correct? We know that those elements separated by a commas are rooster method. We're going to transform this rooster method into a set builder form. So by looking at those numbers 2, 4, 6, 8, 10 or even numbers, then we will just find which among those description has even numbers that are less than 12. For A, x such that x is an odd number, it is not an odd number. And for letter C, x such that x is a multiple of 3 less than 12. So all those given numbers are not multiple by 3 because 2 cannot be divided by 3. 4 is not also. 6, yes, because 6 can be divided by 3. The answer is 2. And 8 and 10 are not multiple by 3. So it's not the correct option. Let's have letter D. X such that x is a factor of 12. So only those 2, 4, 6 are the factor of 12. The 8 and 10 is not factor of 12. And the only correct answer here is letter V. An even number less than 12. For number 2, who is the proponent of the set theory? So we only have George Cantor. Remember that Leonardo Pisa is the proponent of Fibonacci sequence, a sequence that always started with 1 and 1. Let's move on for number 3. What is a set? Well, a set is a well-defined collection of distinct objects. It's not a random collection, it's not a group related, and also it's not a group variable. It's always a well-defined collection of distinct objects, a unique object. For number 4, which symbol denotes that an object is an element of a set? For letter A, it is symbol for not element. For letter B, it's a symbol for a subset. For letter D, it is a symbol for proper subset. And the only answer here is letter C, a symbol for element. Which of the following is an example of a set? A. The set of all months in a year. For us to identify a set, it should be a distinct and well defined. So we can define here the months in a year, or we can identify. But before we proceed, let's try letter B, the set of all tall people in the campus. Here we cannot identify because it's a very subjective. It's depend on how we can see that guy, if it's tall or not. For letter C, the set of beautiful flowers. This is also a subjective. We cannot identify which is beautiful or not. There is no reference for a flower to be called beautiful. Then D, the set of expensive things on student's bag. Here we cannot also identify. So the only answer here is letter A, the set of all months in a year. Because we can identify the 12 months in a year. Now 6, which notation is described as listing all elements separated by commas. So listing elements or listing notation, and another term for that is roster method. So example for that is the given a set of a, e, u. So the answer is letter C, roster method. Number 7. Which notation uses rules or properties to describe elements of a set? Rules there is that the x such that x, then you're going to transform those describing words into a mathematical word. So the only answer here is the set builder notation. For 8, which of the following is an infinite set? Meaning those elements that are uncountable, cannot be identified, or that is beyond on our counting of capacity. For A, the vowel letters in the English alphabet, we can count those 5 letters. Let's have letter C, the set of months in a year. So we can also count the 12 months in a year and we can identify those. The set of letters in the word mathematics. We can also count and identify the distinct letters in the word mathematics. Letter B, the set of even numbers. So here there's no boundary given. So it is considered infinite and that would be the answer. For 9, what do you call a set with no elements? It's just so simple. No elements, meaning it's either null set or empty set. So the answer is letter C. What is the unit set? So a unit set, a set with only one element. By looking at the choices, the correct answer is letter A. So a set with no element, it is empty or null set. A set with multiple elements or infinite set. And so with letter D, a set with infinite elements. So the correct answer is letter A. #11. What is the symbol for the universal set usually denoted by? A, it's a symbol for null set. And letter C, it is a symbol for whole numbers. And N, in natural or counting numbers. And the only answer is B. What is the cardinal number of a set? So here, remember that cardinal number are just the number of elements inside a set. Let's have letter D, a unit number in the set. That's not what we're looking for. The order number in the set. Wrong. The number of elements in the set is, we have B. For 13, which of the following represent the empty set correctly? This one, A, we have an element which is 0. For letter D, we also have 1 and 2 as an element. And our choices now is either B or letter C. So the best choice here is letter B for empty set. For C, it is a repetition of combination of empty and null set. So here, our best option is letter B. If F is a set of 10, what type of set is F? So by looking on the given, we only have one element. Remember, the set with one element is called unit set. If D is a set of X such that X is an element of N and there is a natural number, then D is, since there's no boundary given on the set builder notation, so it is an infinite set, just like a set of 1, 2, 3, and so on. Let's see equals to a set of 1, 2, 3 up to 99. Which statement is true? C is finite because it has 99 elements, or C is the infinite because it contains natural numbers. Though it contains natural numbers, but it starts in 1 to 99. It's not infinite. C is a power set because it has a fixed element. So here, we don't discuss yet the power set. The correct answer here is letter A. So this is the final number for our review. Good luck on your exam and God bless us all.